I'll launch now. I'll start the session.
Yes. I've swapped.
So,
okay, let's go.
Welcome everyone for the second webinar that we are hosting on space traffic management. So I'm François Mazière from Share My Space. This is a French space situational awareness company. I will be your host today with Nicolas Giacomin.
Hello everyone.
He's a space lawyer. Hi Nicolas. Space lawyer and is a member of the Space Legal Issue. That's a website dedicated on space law. So before I introduce our guests, some practical info today. It will be a 45-minute session with our three guests, and that will be followed with a 15-minute question, which you can ask in the chat here. And at the end of the session, we'll have a networking event in Wonder, so the link is on LinkedIn. And Nicolas, want to tell us more about the organization on your side?
Yes, I will. So hello everyone. I'm Nicolas Giacomin from Space Legal Issues. I would like to share you some elements concerning the progress of the webinar. First of all, this webinar is broadcast and recorded on twitch.tv. During the webinar, feel free to ask any question you want. We will select a question and discuss them before the end. After the talk event, a network event will take place on Wonder platform. And finally, you can find all the useful links in Wonder chats or in description below the Twitch broadcast. That's it. Thank you.
Thank you, Nicolas. So let's start now with what we started a few weeks ago with our first webinar on space traffic management. And on the first session, we discussed mainly the general topics on what's happening in space and the risk of collision between debris and satellites. So today, I'd like to introduce a bit more the management of this activity in space. And for this today, we'll have three speakers. So Robin is a manager at Robin Pradal is manager as a PricewaterhouseCoopers space practice in France. He has more than 6 years experience working in the space and consulting sector. He has led and participated in several strategic assessments in the field of space surveillance and tracking and space traffic management for the European Commission and European National Space Agencies. And as part of the IHEDN program, Robin is also providing lectures to the European Security and Defense College on the topic of SST and STM, and is a regular lecturer at SuperHero. So we have also Paul Vohrer. He is a lead researcher at the Foundation for the Strategic Research in France, so Fondation pour la Recherche Stratégique. And since November 16, he has participated in several studies and papers for the French and European institutions, subjects going from security policies, innovation, and also space technologies. He's focused primarily on the space sector and the use of defense sector. You can also listen to several of these podcasts on the FRS website. And as the third speaker today, we have Louis Bouillon-Matignon. He's a space law expert, a good friend of mine, and above all, a fantastic entrepreneur. He has founded Space Legal Issue, this website on space law articles, and also Gamma, a company providing solar sail as a propulsion solar sail mission in France. So everyone, everyone is with us? You have all your camera on? Paul, are you fine? Yes. So maybe today we start with Robin. So we hear a lot of space traffic management for satellites, for debris. Last time we discussed a lot about the risk in space. But what does that really mean, this term, space traffic management, and how can you set the scene for us today?
Absolutely. Thank you very much, Francois, and hello and good afternoon to everybody. Thank you, Francois and Share My Space, for organizing this webinar. And thank you for your question. So I think it's a very relevant question. Before discussing a bit about the different concepts defining space traffic management, I think it's important to understand what is at stake, what are the different challenges related to pushing towards the definition of such a system of space traffic management. So I think it's important to recall a few numbers and mention the fact that the space environment is currently, well, in the space environment we are currently observing more than 25,000 space objects. So this includes active satellites, active spacecraft, but also debris. Just to give you an idea, within these 25K observed objects, so we have a population of roughly 4,400 active satellites, and the orbital regime, which is the most populated, is the LEO regime. So in this orbit we have something like 2,600. So the numbers keep on changing with additional launches, but these are the big numbers that we have, and one of the key drivers towards this need to, the people starting to think that there's this need to define an STM system is the fact that in LEO in particular we are observing quite an important increase of the population. So to give you to illustrate such increase, in 2020 1,100 satellites were launched in this regime, and the regime is currently composed of 2,600 satellites. So the population has nearly doubled, a bit less than doubled in just 1 year. So this is mainly due to the development of mega constellation projects. So with such an increase of the population of space objects, and with the obligation and importance to sustain the safety of the space environment, institutional actors and also commercial actors in the space sector are developing, starting to put forward a system that would regulate and manage the space traffic. So yeah, that's space traffic is one of the options. Space traffic management, sorry, is one of the options to overcome this threat issue concern of a growing population of space objects. So today I will just give you a definition that I have developed with my colleagues at PwC, of course, but just to let you know, there's not one single definition of STM. We can find several, but the way we like to think of STM is basically considering all the different components of the life cycle framing a space mission and saying, okay, what are the STM activities within these components? So I'm going to give you my definition of STM. Of course, this can be challenging. I think there may be, probably it would be interesting to have this discussion on other perspectives on what is STM. But for me and for us at PwC, space traffic management is a system of standards, requirements, guidelines, and technical, programmatic, and organizational activities applied to each component of the life cycle of a space mission in order to ensure a safe access and utilization of the space environment. So STM activities are carried out by both the owner of the space mission, of the spacecraft, and external entities, which play a role in validating, monitoring, supervising, and authorizing the activities to be carried out during the space mission's life cycle. So this is our definition. Of course, as I said, this is one perspective, our perspective, but it can be completed or challenged by other perspectives. Just to recall the different life cycle of a space mission, so and the different activities of STM. during the first phase of a space mission life cycle, it's the concept exploration and the definition of mission objectives. So here, basically, there should be a set of, so STM activities would be composed of a set of guidelines, binding guidelines that would encourage the owner of the spacecraft, the future operator, to develop mission concepts that include space operation sustainability and safety considerations. So when the mission is being designed, safety must be considered during this phase. The second phase is, of course, the design, integration, and testing. So here we see that STM activities can be typically certification processes that ensure that the different subsystems of the spacecraft are compliant with the different technical features, but also do not pose a threat to the space environment. The third phase, which is basically the launch and early orbit phase, here there should be a verification process assessing whether the trajectory of the launch vehicle injecting the spacecraft is clear of any other space object. So this is part of one aspect of STM. The fourth phase is nominal operations, which is basically the longest phase in the life cycle of a spacecraft. And here STM activities could be, of course, the monitoring of the trajectory of the spacecraft, and examining basically the health of the satellite, examining its capabilities, and in case of the identification of a potential collision threat, well, first of all, there's the importance to notify this threat, but also assist, support the operator in conducting collision avoidance maneuvers. And these activities already exist. And there are a set of capabilities that enable these activities, but there's no overall system that basically is coordinated and harmonized to ensure these activities. And of course, the fifth phase, which is absolutely key, is the decommissioning of the spacecraft, which is once the spacecraft reaches its end of life, it is absolutely important to monitor and certify the fact that the satellite has been correctly decommissioned. So yeah, this is our vision of STM, and the way we frame it is to consider all the STM activities within the different phases of the life cycle composing a space mission. Yeah.
Thank you, Robin. Maybe Paul will add his thoughts also on what's going on now, and in particular also what's going on in Europe regarding tackling this challenge. Paul, are you still with us? Yeah. I think the sound is not coming out. You can disconnect and reconnect maybe. No problem.
Technical issues.
So just to follow on the introduction and the why is it now a concern, what's changing, and how what we're doing now. Up to you.
Okay, so if everything is working correctly, I just want to start with a short disclaimer, because after this this analysis, I'll be providing a presentation of one of the current European project dedicated to tackling this issue and thinking about space traffic management. But I want to emphasize first that the views and analysis that I will be providing during this workshop are only my own, and that they do not necessarily reflect the position of the Spaceways Project Consortium and of the Spaceways project in general. So now that's out of the way, I want to first emphasize on one point that Robin has raised, because as he said, the situation in space is changing, and it's changing very fast, actually. That's one of the main points. For instance, if I can give you a couple numbers, as he did, basically prior to 2013, we generally had a little over 100 satellites launched per year. That was on average. and since then the number of launches has grown. So the previous framework of regulation and of space management, basically, there was no such thing as a solid framework where there was a framework that was managed by the United States Department of Defense that provided space surveillance capabilities and collision avoidance notices to satellite operators, but it was not, in a sense, established as a collectively agreed upon framework, etc. It was more of a service to guarantee the safety of spaceflight. But since put it around 2013, because that's where we see a big expansion of the number of satellites launched into space. We saw first 200 satellites launched per year. That was when the renewal of certain constellations, such as Iridium constellation, came into place, and also that we saw a big increase in the number of small satellite launches. In 2018, we had around 400 satellites launched. In 2019, 583, among them the first batch of Starlink satellites from SpaceX, so around 80 satellites, 79. In 2020, as Robin mentioned, there were more than 1,000 satellites launched, 1,200 satellites launched, among which the Starlink constellation actually amounts to something like 800 of them, which is about about 2/3 of the grand total. And in 2021, up until this point, there were 1,185 satellites launched up to now, and it's only we're only in June of 2021. So we can see that the population increase in space is really remarkable, and it's a very impressive increase in a very short time. So that's what this new situation brings on. It's that a sector that developed normally more, let's say, more slowly over time, is actually rapidly changing, and it's increasing in population very fast. So it increases considerably, mainly because of mega constellation projects and small satellites, but also other activities that we're going to touch upon a bit later. And that's potentially a very important problem, because in the case of space collisions, as you know, basically at this type of speeds that are more than 20,000 kilometers per hour, metal is basically acting like a liquid, and so pieces of debris are thrown into space. And for instance, in 29, we had a collision between an Iridium satellite and a decommissioned Soviet satellite, and that generated more than 2,000 debris that are absolutely uncontrolled, and that are a constant, that pose a constant risk to operational satellites. So I think everybody has in mind now the Kessler syndrome that we briefly mentioned. Like in the movie Gravity, although it could be a bit slower in reality. Collision between satellites are becoming a chain reaction, and that could potentially be have the potential to impede the access to especially to low Earth orbits that are currently very useful. So it's an important problem. Not all orbits are threatened by this kind of risk equally. For instance, medium Earth orbit, as Robin mentioned, are a bit less concerned because there are fewer satellites there. There are the GPS, the navigation, positioning, and timing satellites constellation around these altitudes. And the geostationary belt is also a bit less concerned, although it has another set of challenges that is very typical to this particular orbit. But the real problem that we see now is occurring in low Earth orbit, there is the majority of scientific satellites, of climate study satellites, of basically Earth observation, and intelligence satellites also. There is a lot of military activity going on in low Earth orbit. And of course, there are also human spaceflight activities such as the International Space Station orbiting there. And now that we see this new satellite constellation appearing, it appears that the current framework for managing space activities is not up to the task and is not capable of managing this type of increase in space activities. So briefly, what's being done to address the problem? I think there are I could see 5 elements in there. First of all, the first initiative is to improve space surveillance. There are new capabilities being developed, and also institutional organizations such as the USST that gather this type of space surveillance data. In Europe, USST is the main actor in that domain. It gathers a lot of space surveillance data to provide services to satellite operators. The architecture that we used was actually based mainly on Cold War era early warning radar for missile warning, and so new capabilities are developed specifically for space surveillance capabilities. We have in the US, the Department of Defense is putting into action the space fence on Kwajalein Atoll. That is typically a system that is capable of looking at objects fewer than 10 centimeters in size, which is something that we don't have a good understanding now, the debris that are less than 10 centimeters in size. And commercial entities are also starting to tackle this problem and are putting up new types of radar. I won't quote all the capabilities because I know that Share My Space is also a part of this group. Secondly, I think the way collision warnings are issued is changing. I think Robin is going to touch upon that a little bit later on, because basically the US DoD, the Department of Defense, was responsible for the effort up until the release of Space Policy Directive 3, and it's stated to pass this responsibility to a civilian agency, which is the Department of Commerce, and they want to create an open source database to include both military and commercial data sources. So that's another type of improvement that is being done for space surveillance and services. Third, there is the possibility of technical cooperation between space operators. For instance, the Space Data Association was founded in 2009. It's a group of satellite operators that share a satellite position to better coordinate maneuvers. There are new technologies being developed in space, such as active debris removal techniques that we are also going to touch upon a little bit later. And fifth, there is a policy development that is a policy and legal development. And I believe that's what today poses the most challenges, since not all countries share the same perspective on those issues, and it's pretty complicated to get an international agreement on all those issues. So on that note, I would like to quickly present you a project that I have the privilege to be part of, which is called Spaceways. It's an Horizon 2020 project that is part of the research and development program of the European Union. Can you see the presentation?
Yes, and if you cannot see it in large screen, I guess people should click on your picture.
Okay, very well. So I'm going to quickly present you the Spaceways project. The objectives of the overall work program that Spaceways is part of It's called Leadership in Enabling and Industrial Technologies Space, which aims at reinforcing Europe's autonomy in accessing and using space in a secure and safe environment. It aims at maximizing the benefits of space for society and the EU economy. It also aims at fostering a globally competitive and innovative European space sector and at strengthening Europe's role as a global actor and promoting international cooperation. So the Spaceways project will establish over the course of 18 months, so we're 6 months in now, an assessment of technical and policy-related issues associated with the notion of space traffic management. And it will also propose a set of policy recommendations to European Union stakeholders. One of the main goals will be to characterize and understand the context of STM, especially in its international and domestic dimensions. There are current standardization efforts that are pushed at national levels today that have the potential to set norms in a domain that remains largely unregulated. So Spaceways will focus on two main aspects of STM, an analysis of European capabilities and technology gaps, and a policy, legal, and economic assessment of this domain, which will lead to recommendations and guidelines. The objectives are to create a link with stakeholders and communities that are interested in this issue, assessing European technical capability with respect to STM requirements, assessing the legal and policy framework for STM, proposing guidelines and best practices for STM in line with European interests, and contributing finally to the widest dissemination of guidelines and recommendations that will be produced by the project. So the activities that we are doing at the moment was to create a stakeholder engagement platform to ensure the study outputs are embraced by the whole European space community. External stakeholders, meaning external to the consortium, to the Spaceways Consortium, such as satellite operators and ground system manufacturers, will be actively involved with the stakeholders engagement program and through their regular contacts with our industrial partners. And as a result, Spaceways intends to offer normative ways forward with the aim to develop governance perspectives on STM during the project. There is also an assessment of the current legal, policy and economic framework. The main objective is to establish current legal, policy and economic framework of space traffic. It will provide a baseline upon which to build recommendations that will be produced within another work package. It will provide an assessment of the current legal framework, an assessment of the policy level framework and challenges, an assessment of the economic viability and European competitiveness, an assessment of the lessons learned from the existing air traffic management models with analogies and limitations. It will also provide an SSA, SST technological analysis for STM monitoring to provide an analysis of future SSA, meaning space situational awareness, and SST space surveillance and traffic or technological challenges, and focus on the requirements in terms of data collection, processing, and integration. And it will also provide technical regulations for the sustainable use of space. So the main objective is to identify potential STM technical regulations such as principles, norms, rules of operation for sustainable use of space, and the convergence between the space traffic management technical regulations and required evolution of space surveillance assets supporting space traffic monitoring will be ensured in another VP, which is the recommendations. So the recommendations, their objective is to translate the results of the project into a coherent set of recommendations to pave the way for a successful approach to STM in Europe. It will propose options and action plans for the development of an approach of STM in Europe and recommendations based on policy and technical analysis carried out during the project. And finally, there is a dissemination and a communication aspect, an outreach aspect to this project, which will aim at promoting the results of the project internally and externally, either to policymakers, researchers, experts, industry representatives, students, journalists, and interested members of the public. And you can follow the project on our various social media accounts.
Yeah, thank you, Paul. You mentioned regulation and there were some questions, so I'll leave them for the end. But thank you for highlighting what's going on in Europe in particular. You mentioned also what's going on in the US. Robin, do you want to share your view on the difference between what's happening in Europe and US?
Really, so I think Paul highlighted the fact that the US has defined this the national space strategy, and there are several initiatives underpinning this strategy. And you mentioned the Space Policy Directive 3. So just to give you an overview, this strategy aims at reaching three main objectives, answering national needs in three main sectors. The first one is military needs, of course, so developing capabilities, ensuring defense and security aspects, national defense and security aspects are sustained. The second objective is to provide answers to civilian needs. And the third one is to develop and encourage the development of the commercial ecosystem of national US entities. So the SPD3 really aims with, as Paul mentioned, with the Department of Commerce being in charge of the development of the potential STM framework. This gives an idea of how the US is positioning itself in the commercial sector to really develop this landscape, this national landscape of a competitive set of actors offering STM solutions, not only at national level but also at international level. So should an STM framework be adopted in the future and be applied, well, these are a lot of assumptions, but be applied at international level, whatever system, if it's one STM system defined by the US or a system that is defined and the architecture is defined by several institutions, international institutions, whatever scenario, basically the US is making sure that at commercial level they already have a step ahead of other territories, other areas, and will be equipped to offer competitive, efficient capabilities to ensure STM services. So this is the strategy of the US. So this implies the fact that at European level, initiatives are being examined to what kind of positioning at commercial level the EU has to take. This is an open question and it's currently being examined. We will see what will be the positioning of the EU in response to such US positioning. But yeah, basically the development of the commercial ecosystem of actors is a key component to consider within the development of an STM system.
Yeah, I can say I'm particularly involved in knowing about that, being working for a company with a commercial player, and there is a lot of difference with Europe and the US in terms of commercial playing field. But okay, that's for sustaining the SSA and space situational awareness activities. But talking on the commercial sector overall, Paul, you mentioned also several new activities going to be happening in space, and several of them will be commercial, and they're also that's very exciting to talk about.
Yes, absolutely. There are new types of activities that are being developed in space. Just to give you a little bit of context of basically what is happening in space, there are new types of civilian activities. Some are quite experimental at the moment, but recent experiments have shown that they work, such as satellite servicing. Satellite servicing is basically what we call a rendezvous and proximity operation that aims at refueling or updating some components of a satellite that has been in space for a period of time, and making sure that it can operate for a longer period. So that's the type of activity that we see, and it's a very new type of activity. Actually, this has never been the case before. It's except in the very specific case of human spaceflight, where we had spacecraft flying and refueling other spacecraft. One other type of activity that I can mention is active debris removal, for instance. It's the same type of idea, but active debris removal is an operation, is a rendezvous operation that entails working with a non-cooperative target, because a debris can be a piece of a spacecraft that has been removed. It's an object that can tumble and that is very difficult to grab, and so but it's a capability that might be needed to make sure that the safety of space flight and the sustained use of space is safe for longer periods. So there are a lot of activities that are being developed to this purpose. And of course, there are also new types of military activities in space, and that's an entirely new trend also, since the United States and several other countries now consider that space has become a war-fighting domain, and that and people are now fearing the weaponization of outer space to some extent. We have seen anti-satellite testing and anti-satellite operations raising for around 2 decades now. The first test that was a real eye-opener to the community was the 2007 China anti-satellite test. There was a subsequent US operation in 2008 that destroyed another satellite. In 2019, India also launched a kinetic anti-satellite missile that destroyed also a test satellite. And there are a lot of other types of anti-satellite or more broadly counter-space capabilities that are being developed, that are more discrete for some of them, that are not even physical, that could be jamming capabilities, blinding capabilities, or directed energy capabilities, or cyber capabilities, and that's also a new trend that we see happening. So the military has to, in a way, integrate all these new military actors around the world, have to integrate these new activities in space and learn how to work with them, and what also are the rules, especially the rules of engagement in space, to understand what is legal, what is not allowed in different types of situations. And so that's parallel to the civilian trend of increased activities in space. You have also a military trend of increased activity in space.
And that's a challenge for understanding what's going on over there, because now satellites are starting to get close to each other, talk to each other, grab each other. So that's a whole lot of new things for space traffic management.
Absolutely.
And there are obviously legal implications of this, and as we have Louis there, I mean, is there for you a clear path on how on-orbit operations and space traffic management is framed from a legal perspective?
Can you hear me well? I'm sorry, I'm
Yes.
in a chat room, so other people are talking. The first thing that people have to understand, I believe, is that when we're talking about STM, space traffic management, we're mainly talking about low Earth orbit, since past commercial satellites were launched in geostationary orbit, and the geostationary orbit is well organized by an institution called ITU, the International Telecommunication Union, which is also going to tackle low Earth orbit subjects. It's going to position itself in the upcoming month on allowing frequencies and allowing slots in the LEO belt. I've just learned that yesterday from the French Space Army, the Commandement d'Espace. There was a conference speaking about how ITU was going to manage low Earth orbit. So when we're talking about space traffic management, we're mainly talking about low Earth orbits. We're not talking about geostationary orbit or deep space. There's been a boom in the number of satellites launched in the upcoming years, like Paul said, especially since the mid-2010s. Today the big question is how are we going to find some standards, either international standards, legal standards, or maybe some, some form of compliance and some form of regulation throughout the practice of space activities. The idea is that some states today have tried to tackle all of those issues, especially the French space law with the Loi sur les opérations spatiales du 3 juin 2008 from June 3, 2008, which basically asks satellite operators to basically deorbit the satellite in a 25-year period once the mission is finished. But all the traditional actors that were involved in space law, especially the United Nations, have not yet find a way to basically gather all the space actors around the table to find out some new standards. So there's a big activity that we've just talked about involving what we call space tugs or space vans. The idea is that with on-orbit servicing, we could basically manage satellites in low Earth orbit, and by satellites, basically there are two different directions. The first one is active satellites, the second one is inactive satellites. So that's the first understanding we have to have concerning the project. I mean, some satellites are still working in space, so they can be basically moved in space, they can basically do any operations in space, but some satellites are now what we call space debris. And those two different directions imply two different set of laws, and it's pretty hard to find some standards today. It's also the idea of how we're going to basically standardize low Earth orbits in order to guarantee the most efficient use of orbits, because I recall that the Outer Space Treaty of 1967 basically says that space is for everyone, that we cannot basically nationalize any part of outer space. And there has been some concern regarding all the mega constellations projects. Was it a way to basically nationalize some part of the outer space? So that was a pretty interesting question. But the thing is, today we have to find some standards, and it's true that states have difficulties to find those standards. Again, United Nations have difficulties, and national states have difficulties. So the idea is maybe to use the contract as a first way to basically manage on-orbit servicing operations. And that's what I've written in my PhD thesis. I believe the contract's the best tool today that is available for space actors and space operators to deal with all of those kind of new operations, because as Robin said and Paul said, what we are dealing with, it's very fast progressing activity that did not exist 10 years ago or 20 years ago, so we have to find new instruments. But today, basically, international law doesn't really deal with space traffic management, nor does national laws. So there are going to be some standards set it out. Paul told us about some of those standards: national standards, American standards, European standards, regional standards, but also company standards. And I think maybe the solution will also be with the contract that I just said. So that's what can be said quickly regarding STM from a legal point of view.
Yeah, and you also mentioned UN regulations, so there was a question about it. So there is only a general level of regulation, but no. Well, what's the status for UN regulation regarding space traffic management?
So basically, the UN was the place where space law was born, kind of. I mean, it was born with practice and the jus cogens, as we say in Latin, but it was basically enacted by the UN in the 1950s, 1960s, 1970s. And the idea is that the UN was the main body for framing space law, but it hasn't done very much work since the 1970s. It has actually tried to do some work with some resolutions, with some projects, with some guidelines, with any other stuff that's not really considered as hard law, but only soft law. And the problem is soft law is not today convenient for dealing with that kind of operation. So today the UN has not taken any decision regarding space traffic management, but as I was telling you, ITU might take some position in the upcoming months, so that might be one of the international organizations taking place in the STM management. So for now, no, the UN hasn't done anything but soft law and guidelines. More, it was a really quick, short in time, so it's pretty hard for me, but I don't know, Francois, we can't hear you anymore. Do you hear us? I don't know if you, Paul or Robin, have something to add concerning what I've just said.
Yeah,
I mean,
François.
I fully agree with you. I think international law is very, very hard to create right now. It's probably also due to the general context. Actually, there has been a lot of initiatives put together. Russia and China are promoting the PPWT. There were the long-term guidelines also that were issued, but as you mentioned, these are only soft law instruments and are and it's difficult today. I think it's part of the context mainly to agree on such regulations internationally. However, there are national regulations that are binding to some actors. In the US, for instance, you have the ODMSP, which stands for the Orbital Debris Mitigation Standard Practice. There are waivers sometimes issued for certain missions for NASA and the Department of Defense. But generally, it's a type of regulation that is agreed upon nationally and that you have to generally comply with to be able to launch a satellite. I don't know what's your view on that, but that's another instrument. The problem is that it does not really help, in my opinion. Again, I reiterate, these are my views on with the coordination with other actors.
If I may, just very quickly, I just wanted to add, I fully agree with Louis and Tom's analysis on this, but just to, my point of view is that it will be very challenging in the future, as you mentioned, to have to imagine an STM international system that works, functions upon a set of binding rules. I think it's a scenario that we can exclude, just maybe for people who are listening who are not familiar with this. It will be very difficult to assume and see this kind of scenario, a set of international binding rules. It's very challenging, but it's a challenge because STM is an area which includes many legal gaps that have to be addressed. And I think, as you mentioned, there are some national binding rules. In France, we have La LOS, but yeah, it's something we need to be aware of.
Maybe we have to remember that we actually found a way to manage our air traffic. So even though and some people told me when I was arguing with them that satellite operations in low Earth orbit can be military, and sometimes states don't want anything to do with military, etc. So they don't want to say what the satellites are, etc. But the thing is, we still do have the same kind of situation on Earth in the air. So I'm not sure if we're not going to find. Maybe it won't be some regulations set it out for the entire world, but there will be some guidelines, and I think it's just mandatory that we observe those guidelines, because as we've witnessed this recently, I mean, ESA had a satellite that maybe could have hit it, a SpaceX, a Starlink satellites. We had issues with other satellites, being on course. We have had issues with debris, etc., etc. I'm sure we have to find a way to basically centralize all the information. And I think it will be more transparent and more. Of course, that's my wish, but it's not maybe the reality. But I think it's kind of important. We find a way to standardize all those information and to share them with all space actors. It's mandatory. We're doing that on seas. We're doing that on the air. We're kind of doing that in the Antarctic in some ways. So the international environment that is outer space should also obey that kind of stages and that kind of organization, I believe.
Thank you, Louis. There was a question in the audience on a particular subject. If you have seen it, I think it's for maybe Robin or Paul. The Europe's plan for building out space surveillance network to ensure sufficient situational awareness given the growth in the object. So I think we answered already partially what was going on, but I mean, who is doing that?
How to answer this? For instance, the current framework is EU USST. But regarding the plans that Europe has for the development of such capabilities, I think it's, Nourba mentioned it, I think it's still very much in the discussions, and that's part of a broader reflection at the European level, I think.
Yeah, if I may add, I think it's important to underline the fact that the USST is delivering some very high quality products, and it has expanded recently. It was initially composed of 5 member states, and which were France, Spain, Germany, UK, and Italy, and it has expanded recently. It included Poland, Portugal, and Romania. And with such an expansion of its network, of course, these 3 new member states are bringing in new capabilities. So this is something that is being developed. So there are some initiatives in order to cover this at the European level, at least in the field of SST, in order to cover this. And well, the expansion of the network is one example. The US, they have developed the Space Fence, which is basically a radar which has very high capabilities, which is expected to really increase the catalog of observed objects. And in Europe, we have basically today I think the US and the EU work hand in hand on this, on the provision of data, with the US providing a lot of data, of course, to EU actors. But where the EU has a real role to play and a position to take, and is already taking its position, is on the observation of other orbital regimes, such as in MEO and LEO and GEO.
Okay.
We have quite a lot of very interesting optical capabilities and a very interesting optical network. And the arrival of these 3 new member states is expanding, of course, this network.
Okay, thank you for so now we have so there will be a networking event. So we have finished the panel discussion. So when we break the panel, people will be able to join and talk together. So stay with us if you want to discuss a little bit on space situational awareness and all those interesting and fantastic topics. We'll have another session in a couple of weeks, more regarding end of life, and inviting 2 companies, one from Finland and one from Italy, as a panelist. And until then, I tell you bye-bye and see you in the chat room. Thank you for the audience.
Bye,
and
everyone.
Thank you for the panelists for your participation.